Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to function operations. I really do think that most of this video is going to be just needing to assimilate a new way of writing to something that you already know how to do. So for example, I'm going to have f of x equal x squared plus 5x minus 9 and g of x equaling x minus 8. We'll go ahead and make that 3x minus 8. So there are several function operations that we're going to cover in here. We're going to cover adding, subtracting, multiplying, dividing, and composition functions. These four probably are going to be pretty familiar, and the compositions, when we get there, it's going to make sense, but it just might be a little different at first. So they're going to write the adding function as either f plus g, or they're going to write it f of x plus g of x, or they're going to write it just f plus g. It depends on which way they want to format it. Keep in mind the parenthesis x here is just telling you what your variable is. So let's say we want to do f of x plus g of x. Okay, this is a substitution problem. We are going to, instead of writing f of x, we're going to substitute what it equals. And I always like to substitute in parentheses. It saves sign errors. And then we're going to substitute for g of x. G of x is 3x minus 8. And again, I like to substitute in parentheses. In this case, our parentheses are not really doing anything except holding those binomials together or that trinomial together. So technically, we can distribute the plus sign or just drop them. You've seen this kind of problem before. You called it adding like terms. So when we add like terms, we get x squared plus 8x minus 17. That's it, we're done. Notice how there's no equal sign here? Since there's no equal sign, we're not solving for x. We are just doing the equation named f plus the equation named g. So I'd like you to go ahead and try f minus g of x on your own. If you need to, go ahead and hit pause. I'm going to use arrow notation since technically there's no equal sign. So f minus g of x. Well, I'm going to take my f equation minus my g equation. Then I'm going to be very careful there because that minus sign does need to distribute. So x squared plus 5x minus 9 minus 3x plus 8. Careful, that sign error is one that's very common because some people don't substitute using parentheses and they forget to distribute the minus sign. So that gives us x squared plus, that should have been a 9 right there, plus 2x minus 1. That would be our final answer. So I'm just going to give us a new f. Our new f equation is going to be named, or is x squared minus 9. And our g of x is x plus 3. And I did that just to help us shorten our notes up a little bit. So now we're going to do f dot g, f times g, right? Or it might be written f times g of x. Okay, well, I'm going to take the equation named f of x and multiply it by the equation named g of x. X squared minus 9 needs to get multiplied by x plus 3. Hey, that's a FOIL problem. First, outside, inside, last. And there's nothing else we can do because there's no like terms to add together. That's done. So what about f? Oh, let me write that correctly. I had a couple things in my head at one time. F divided by g. Well, Well, the first thing is when we have f divided by g, we have to be careful because domain errors that did not occur in f and g are going to suddenly occur because we're going to be taking x squared minus 9 divided by x plus 3. So right there we have to note that even though negative 3 was okay originally in g, negative 3 is no longer okay. So note that x cannot be negative 3. And generally you're either going to long divide or synthetically divide, or in this case I'm going to utilize factoring. I happen to know that x squared minus 9 is x plus 3 times x minus 3, and the x plus 3's will cancel. So f divided by g is going to reduce down to just x minus 3, with a side note that x cannot be negative 3. With these four operations, assume your domain is all reals. Except when you have radicals with an even index or division where variables are in the denominator. Okay, so if you don't have one of those two cases, then your domain's probably all reals at this point in your mathematical career. If there's division with variables, like right here, we had an x in the denominator, hence why we had to get rid of negative 3, or if you have a radical, then you're going to have issues with your domain. Otherwise, it's probably, not guaranteed, but probably all reals. So add, subtract, multiply, and divide, you've actually done previously in your math classes. You combined it like adding like terms, subtracting like terms, FOIL, and I know I've done a video of division of polynomials already. But then there's this open circle thing, and you might see it as you're going to have to make sure that you notice that it's not colored in. And I have some students that call it fog, but that's not actually an O, that's a circle that's not colored in. Or you might see reversed. And this is going to be very important because of the order that it's written in. The first one is read f of g, whereas this is written g of f. Okay? And really it should have an x there, but sometimes they get lazy and they don't write it. What this really means is that one equation is going inside of the other. And you might think, well, why would we use that? We never use that. Actually, computer programmers kind of use it a little bit, or a lot. And you actually experience this whenever you go to the store. Let's say you go to a clothing place and you have them ring up 4 or 5 clothing items, but then you have 20% off, and then they add tax on. They're actually doing this composition function, because they're doing one thing and then the next and then the next. They're not adding your 3 prices together at the end. They're doing a chain reaction. So a composition function is like a chain reaction. It happens every time you buy fuel as well. The pump has to do the fuel price, and then it has to do the tax price. And that can vary based off of location, because there's city tax as well as state tax. So we're going to go ahead and we're going to look at 2 functions, and we're going to see how they vary. Okay, and you can think of it, we'll actually just do a quick one without algebra. Let's say you're going to buy a $100 item. Okay, you have 2 discounts that you get to apply. You have a 20% off, and you have a $10 off. Which should you do first? Okay, so remember 20% off, you do 20% of the number and then you subtract, or it's like doing 0.8 times the price. And you can think about that 20% of 100 is 20, take off $20, you're at 80. 0.8 times 100 is also 80. And then $10 off is just the price minus $10. Okay, so I'm going to call this one F and let's G. Okay, so let's say we start at $100 and we do F and then we do G versus $100, do G and then do F. Okay, so we'd have $100. We'd take off 20% or do 0.8, so we're down to 80. And then we're going to do G, which is our price minus 10, now we're down to 70. Okay, versus here we start at $100 and we take off G. So we take off $10, we're at 90. And then we do our F, which is 20% off of 90. Now we're only saving 18, not 20. So now we're down to 72. Which price do you prefer? The 70 or the 72? You might be like, really, whatever. I don't care too much when it's $100. Well, you would if it were 100,000. So keep that in mind. But that chain reaction, the order that we did it in, really made a difference. So that is one thing to be concerned about, and we can see that chain reactions do have an effect. Now, I did not write it proper mathematics here because I just kind of wanted to talk through it. And just a side note, if they were both percents off, it wouldn't have mattered. If they were both hard dollar values off, it wouldn't have mattered. But because one was a percent and one was a dollar, it did matter. And you can go back and check that to see if I'm telling you the truth or not. If one's a 10% and one's a 20% versus $10 and $20. Okay, so f of x, we're just going to keep it a simple equation, x squared. G of x is going to be 5x plus 2. And the first one we're going to find is f of g of x. I like to go ahead and basically kind of box in. That tells me g of x is going on the inside. So I really should be thinking f g of x. Okay. So I should be thinking f g of x. Oh, see how I substituted? Yeah. Now, in case you forgot, I'm going to do a little side note. In order to do like f of 4, since x is now 4, we'd put the 4 in for the x. We would do 4 squared, which is 16. So when I have f of an equation, that equation still goes in here. So this is now 5x plus 2 squared, which then we would have to FOIL. We get 25x squared plus 10x plus 10x plus 4, or 25x squared plus 10x plus 20x plus 4. Combine those like terms. Okay, so that's one chain reaction. G went into F. If they said f of g of 1, I could do this a couple ways. I could do like this, f of g of 1. So if I put 1 into g, 5 times 1 plus 2, that's 7. And now 7 into f, 7 squared is 49. Or I could come up here and go, okay, well, I'll put 1 into here. 25 times 1 squared plus 20 times 1 plus 4. That would be 25 plus 20 plus 4. Hey, that's also 49. So when they give you a number, you can put 1 into g and g into f. That's perfectly okay. When they give it to you with a variable, you have to give a variable in your answer. So let's go the other way. This time we're going to do g of f, or g of, or g of, we're just substituting x squared into the g equation. We're taking the f equation and popping it into the g equation. That gives us 5, and instead of x, we're replacing it with x squared. So that was a much simpler version. Here I've given us two tables of values, and I do find table of value composition functions to be harder than equation problems. So let's say they wanted us to find f of g of 1. And remember, that is f g of 1. So they wanted us to start off by putting 1 into g. And when I put 1 into g, here's 1, x is 1, we get out 2. So now we're at f of 2. So now we got to come over to the equation into f, and when I put in 2, I get out 1. Yeah. Okay. So we started with an x value of 1, and we ended with a 1. Okay. What if I did 2 instead? Instead of 1, let's change it to 2. So f of g of 2. Okay, well, when I put 2 into g, I get out 0. But over here, they don't tell me what f of 0 is because there's no 0 for an option for my x's. So this is undefined. So I started with a 2, but I couldn't find an ending value. Okay, we've got 2 other numbers for g. So 3. So f of g of 3. And remember, 3's go into g first. So what is g of 3? So here's 3, here's g. We get 4. Oh, can I do that over here? 4? Absolutely, I get 7. So we started with a 3 and we ended with a 7. Okay, can we do 4? 4 goes to 9. Does 9 have that chain reaction anywhere? No, there's no 9 here. So the only times that we could do f of g with an x value was for when x was 1, we got out 1, and when x was 3, we got out 7. Okay. I wonder about the other way around. Let's try that. Let me find a clean piece of paper. Okay. I'm putting it on another paper side by side because I want to be able to see my charts really quickly and I want to be able to compare stuff. So before we did f of g, now we're going to do g of f. So, and I'm going to write this different. Let's start this with x equals 1. So 1 goes to, remember we're starting with x, we're taking 1 and putting it into f. So in f, 1 goes to 3, and 3 went to 4. So we started with 1 and we ended with 4. Okay, and again we did g of f of 1. So we did g of 3, which got us 4. So we started with 1 and we ended with 4. Okay, what about 2? Put 2 into f, we get out 1, and 1 goes to 2. So we started with 2 and ended with 2. 3 goes to -5. Can I do 3? No, there's no -5 as an option. 4 goes to 7. Can I do that? No. So g of f of x worked when we started with 1, we ended with 4, and when we started with 2, we ended with 2. Is that the same ones that we got before? No, they're very different, and that's because we have a different order of doing the math. We either start with F or we start with G. So the order that you do them in really does make a difference if you're given a table of values. If this helped, give it a like and don't forget to Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe. Thanks for learning with me here on Math with Michelle.